Hi students, welcome to InfoWord Tamil TV Maths program. As I have mentioned in my last class, I would like to start with normal distribution. Normal distribution is one of the A-level second year topics, and it isn't the first topic in syllabus. In order to follow this topic, the people who are outside this class require some basic knowledge in statistics. Unfortunately, I can't go through all the basic today, but I'll cover in my GCSE and A-level first year classes. For this particular topic, I would like to go through very basic, which would help you to understand this topic properly or keep you on track with this topic. The statistics. If you understand statistics, the basic of statistics, easy for you to follow any statistics topics. So statistics, the 4 steps approach. 1, collecting data, real world data. Organizing the data. You write the data in a certain form, or create a table, or distribute some graph. That's organize the data. And 3rd, analyze the data. That's you carry out various calculations for particular topic, particular purpose, and then finally predict the outcome or forecast the outcome. That's what statistics is. So let me start with number 1, collecting data. The data will be collected via survey, the various survey. I don't want to go through all of them now, as I said before. So collecting data from survey, then organize the data. So you write in ascending order, you create a table or distribute on a graph. That's where today's topic come up, distribute in normal distribution. And then finally, do some calculation. We look into all the calculation related to normal distribution. And finally, the forecast, what the outcome results is. For this particular topic, as I said, you need to understand mean. Mean, you all know, as you are in A-level second year, you must know what mean is, average. And the next one you need to know, standard deviation. Standard deviation. There are 2 types of mean. One is for the population mean, the population of the entire survey and the mean. And the next one is the sample mean. The sample is a small number of people, or items you survey, and you find mean. Again, when you come to standard deviation, there are 2 types of standard deviation. One is population standard deviation. The other one is sample standard deviation. The mean, the population standard deviation standard deviation. The mean is mu, denoted by mu, and standard deviation is lowercase sigma. So this is, you probably come across that mu for standard deviation, population standard deviation. Mean is the population mean. The next one is standard deviation for population. And mean for sample, mean X bar, and standard deviation S. We don't need to look into that. All we need to concentrate on those 3, mu, sigma, X bar. X bar, we don't need it now, but we will come to know that later on. When you actually collect data, that's the first part is in statistics, collecting data. When you collect the data will be in various form. One is the numerical form or non-numerical form. We concentrate on numerical form. And when you come to numerical form, there are two types. One is the discrete data, and the other one is continuous data. The discrete data is full number or whole number. The continuous data will be decimal number. It could be anything, or infinity variety of, it's a 1.1, 1.1112, or whichever. So it's just continuous data. We are concentrating on continuous data for normal distribution. So a collection of data and continuous data, and we come to normal distribution. Prior to come to normal distribution, when you collect the data, you create a distribution or curve. It may not be as perfect as what we want. So it will be like that. So this type of curve is not quite perfect as normal distribution, but that's a curve. But what this is the positive skewed data. The data is collected and you create a graph. It will be skewed to positive, or it will be skewed to negative. But what we want the normal distribution, a perfect curve or perfect graph. So in order to achieve that, we can actually use central limiting theorem to get the full perfect normal distribution. So for example, this is the population, so the entire number or people, whatever, the whole entire. So there's for this mean, if you find that mean, mu, and as I said, standard deviation for the population. This is population. Population. But if you actually collect the data population, and the graph may not be as good as what we want. So what we do, you actually separate samples within population. There are many samples. The more samples, the better the data, or the better the graph would be. So you find the sample and then find the mean of each sample. So x bar, so x1 bar, x2 bar, x3 bar, and so on. Then you create a graph with that mean. Then the graph will be a perfect graph. This is what the normal distribution is. So forget about what I said. So I'm going to concentrate on normal distribution. Normal distribution is perfect curve. The curve is a bell shape. Bell-shaped curve. It's a perfect bell-shaped curve. And it will be symmetrical about the mu, which is the population mean. Symmetrical. Symmetrical. And the area under the curve is 1. Area under the curve is 1 or 100%. What that is, again, is the probability of a particular activity. So as you know, any particular activity, the probability always be 1. The entire activity, not just a part of the activity. So for example, you toss a coin, the head is half, tail is half. So the entire probability of tossing a coin, the head and tail, is half, is 1. So always is 1. So this normal distribution, as I said, the bell shape, symmetrical about mu, and the area is 1. So that all three characteristics of normal distribution you need to know in order to do some calculations. So let me start with normal distribution. Having gone through all these basic, having explained all these, the normal distribution. So when you come to exam, you probably get an exam question as normally distributed or normal distribution. So without thinking of what I have said before, you just purely concentrate on the graph is a perfect graph. That's mu. So perfect graph is mu. And this is symmetrical about the mu, this line. So in other words, this side, left-hand side of the line is half. The other side of the line is half. So the area this side is 0.5, area this side is 0.5, or area this side is 50%, area this side is 50%. It's purely applicable for the normal distribution. The data is normally distributed. There are various calculations done to achieve this. Having achieved that, that's what we are going to study today. So normal distribution, mu, 1, area is 1. Say, for example, this side is mu, take mu is 50, and then we talked about standard deviation. I'm going to say standard deviation is 10. Standard deviation, I'm not going through what is standard deviation. That's a different topic, and it takes the different explanation to explain what is standard deviation. As I said, we're just thinking these two are mu 50, standard deviation is 10. When you come to this graph, you can actually notate this graph as, say, this way, x. This is the random variable. X is random variable. This is what it is. Which, say, for example, we're actually doing a survey of the height of a people in a particular town. Say, we just say that starting from 150 centimeter to 200 centimeter. So that is the minimum was 150. We just checked it out. And then 200 centimeter. So you do a survey, and then you come across the mean, say 175 or so. But I'm not going through a particular survey. I'm just saying this, the normal distribution, the mu is 50, lambda is 10. And then this can be written, x correspond in mu. This is how we actually represent the curve in the form of the data, or in the form of the known data. X is the random variable along this axis, and correspond n bracket mu lambda squared. N represent the normal distribution. Mu is the mean of what we are talking about, and the lambda is the standard deviation. And you can see lambda squared. Lambda squared is variation. Lambda squared is variation. Variance. Variance. Lambda squared is variance. That's how we represent the graph. So having done that, so we have mu is 50, lambda is 10. So if I want to write that x correspond in normal distribution, that is actually telling you what is normal distribution. Instead of mu, I can put 50. Instead of 10, sorry, instead of sigma is 10. So in other words, 10 squared. So this is how we actually represent the normal distribution. Having known that mu and standard deviation, this is how you actually represent. So in anyone actually see this, you know exactly what is mean is, what is standard deviation, and then do the calculations. Let's start as the basic calculations. Mu is 50, we have said it, and standard deviation, write this, x, this x, correspond normal 50, 10 squared. So standard deviation is 10. I have said the whole of the graph, under the whole of the graph, the area is 1. And again, I have said the graph is the symmetrical about mu. So what I'm saying is, this side of the left-hand side is 50%, that side left-hand is 50%. The probability this side is half, probability that side is half. How we write that? P, when x equal mu. So you can say less than or equal mu or 50, that is equal 0.5. So what this one represents, the half, the left-hand side is less than 50, less than or equal 50. When x is less than or equal 50, what's the probability, which is half? We can actually use the calculator to prove that as well. Well, and come to the calculator in a minute. So if you write this way, x greater than or equal 50, again, the right-hand side, that is also 0.5. So this is very simple. You don't need the calculator to do it. In case you've been asked to find, this is 50, mu equal 50, standard deviation 10, then in case they ask you to find when x equal 35, x equals 35. What they ask you to find, the probability of x less than 35 is what? We need to use the calculator. We can't actually do that without a calculator. So what they're asking you to find, the probability when x less than 35, that is this part, this part. To do that, you need a calculator like this. It's a scientific or mathematical calculator, and in that you can select normal distribution and select option 2 in order to do this calculation. That's the normal distribution. And option 2, you have to select to do the calculation. All right. When you do that, it's ask you the lower limit or the number. What is lower? Well, we don't know what is lower is, but what we know, it cannot go less than 0. So we can actually use the lower value is 0. The lower value is 0. What is upper value? The upper value, we want to find out anything less than 34. So the upper value is 35. And you do that, 0. Low value is 0. The upper value is 35. And standard deviation 10. Mu is 50. All right. The answer is 0.066. So this one, the answer is 0.066. So this much of the area of this area is 0.66. So you need to have the calculator, you know that, of course, the scientific calculator to calculate that. Say if you have, this is purely, I'm sort of guiding you to exam type of questions. So this is not the exam type of question, of course. This is the start of it. So I'm guiding to the exam question, but exam question is a lot more than what we know. All right, let me go into this. The same, the perfect bell shape. We know, I'll still stick with mu is 50, standard deviation 10, and this is, you can write it, x, this is x. Correspond, normal distribution, 50, 10 squared. So as soon as you say that, we know the mu is 50, standard deviation 10, and this is the normal distribution, because it says that having seen this is a normal distribution we are talking about. So I'm going to sort of keep the same example before. Say if they ask you to find that part, say this is 35, this is 65 or whatever. Yeah. So sometime the question will be, what is the probability between 35 and 65? How you write it is x less than or equal 35, sorry, greater than or equal, less than or equal 65. So the question will be asked like that. So what they ask you to find, anything between 35, when the random variable x is anything between 65 and 35, what is the area or what is the probability? So what is the probability? We know that area. So how we can find, two ways to find it. One, of course, there's a table there to do it, but we use the calculator. When you use the calculator, this is the upper value, this is the low value. So when you use the calculator, normal distribution, option 2, it will ask you the lower value, which is 35. Ask you what is the upper value, that is 65. Ask you what's the mu, is 50. Ask you what is standard deviation, is 10. When you do that, then it'll give you the answer. Let's see whether we can find that. So low value, 35. Upper value is 65. The standard deviation, 10. Mu is 50. The answer is 0.866. 0.866. So this part, the data between 35 and 65. So when you actually have a survey, the data between 65 and 35 is about 0.66, which is about 87%. So 87% of the data will lie between 35 and 65 when you have a 50 mu and 10 standard deviation. So 87. So in other words, as I said before, the whole of graph, under the whole of graph, the area is 1. If this is 85% or 87%, this bit and that bit will be 100 minus 87 or 1 minus 0.87. So this area and that area, 1 minus that. So sometimes the question will be asked to find this and that. What is it? If you want to write that and that, the notation for that, x 35 or x greater than 65. This is how they do it. So you can simply, when you actually read it, without thinking about the statistics or normal distribution, you think is all that. But in statistics, when you actually use the word or, what it means is at or plus. So what this one telling you, this area and that area, what is less than 35 plus what is greater than 65, that's what they're asking you. So when you come to exam or when you come to questions from a book, this is what they say. O means at, anything less than 35 plus anything greater than 65. That will be, if you know this value, that will be 100 minus 87, 13%. So a very small amount of data will lie outside 35, outside 65. Then next one. So we actually have in between, we actually have the outside, the middle portion. Let's go into look at what is standard deviation. We know standard deviation. I'm not going to go through all the standard deviation, but in the graph, what we can do is make 50. If I could mark a line, one standard deviation less than the mu, but we know standard deviation is 10. We know mu is 50. This one I'm going to mark it as mu minus standard deviation, which is 50 minus 10 equal 40. And this side I'm going to say mu plus standard deviation, that is 50 plus 10 equal 60. See what this tells you. The data between one standard deviation less and one standard deviation. So in other words, one standard deviation apart. So this bit is, this side is one standard deviation, that side one standard deviation. I can actually prove it. This area will be about 68%. But let's see whether right or wrong. So lower, this side is 40. upper is 60. Standard deviation is 10. We started with 10. And mu is 50. Say the answer is 68.26, roughly about 68. So what we are trying to say, what I'm trying to say, between the one standard deviation, the most of the data, most of the collected data fall between the two standard deviation. But if you actually know standard deviation, what is standard deviation, you understand more. But for this purpose, you just take it between the one standard deviation, between the two plus standard deviation, minus standard deviation, plus standard deviation will be 68%. If I could stretch this side to 2 standard deviation, so mu minus 2 standard deviation, stretch this mu plus 2 standard deviation. Again, you can prove it. That will be roughly about 95%. So in other words, 95% of the collected data will fall between the 2 standard deviation. So the standard deviation gives you an idea what how much the the spread out, the 95%. If you actually stretch it to one more, mu minus 3 standard deviation, mu plus 3 standard deviation, that will be roughly about 97.3. You can prove it with the calculator, but I've done it before, so I'm just writing it down. So 1 standard deviation apart, the other side of the mu, right hand side of the mu, left hand side of the mu is 68% of the data, and 95% of the data, 97% of the data. So in other words, the whole of data will be roughly 3 standard deviation. 3 standard deviation. Right, then going to the calculation, and for the calculation purpose, as I said before, this side, the lower value is 0. That side, in mathematical term, that side infinity. But of course, we can't use infinity. You can use, for this particular topic, the lower value this is 0, and this side, I would say about, say, 1,000. You can put any value, but just 1,000 will be enough to give you the right answer. So the lower value is 0, always 0, you can lower value. The upper value, you have to sort of judge it. This is 50. And then again, as I said, 97.3%, almost all the data, goes to 3rd standard deviation. So at 10, 10, 10. So 50 at 10, 10, 10 is 80. So the maximum, 80 to 100. But I just put 1,000 just to be safe. And this is how you calculate that. The normal distribution we have actually completed so far, which is enough to sort of compile as a question, and we answer the question. The next topic, to continue with this topic, the next subtopic will be inverse normal distribution. We will start inverse normal distribution after the break. Thank you.